This way. Let's begin. Okay, I did have to map out the rest of the semester. So I looked at it, and first things first is 7.5 is on tap for today. And I'm going to give you guys a study guide.
Wait, so we're skipping 7.4?
We're going to skip 7.4. 7.5 is a little more important. It is inequalities. And then we're gonna have a test week next week Wednesday. We've got to in order to fit everything else in. And I'm not sure whether we have class on the 28th.
I don't think we do. It's just electives.
So, okay, so my question mark is confirmed. So let me actually do this one.
He needs to make it an exclamation mark.
I get to put a different one in there. So is that the way it is? Yep. So I am going to send you guys a study guide sometime tonight or very early tomorrow. When you come back on the Monday, we're going to review any questions you guys have and maybe a small game or something like that so we can put things together. Oh, gotcha. Okay. Thank you so much. Let's see. Let's do this here, Dylan. I'm going to take your questions if we have any time at the end of class today, which I don't think so. If not, I'm going to make a video of it. We're good? I'll do a video of homework just because we need to move on. 28, no class. Memorial Day, no class. So then we come back. We're going to start chapter 8 on that Wednesday. I give you your chapter 7 exams back. We do 8.2, 8.3, give you corrections, 8.4, and we really don't have time to take an chapter 8 test. So we're going to incorporate it into the final. Are we good? Because we have this, we have presentations to do.
And he wrote verbal again.
The presentations are the best.
Then we have
Finals, to be honest. They're not.
Wait, why is there all the numbers?
verbal oral. Thank you so much. There
you go.
Thank you. I was thinking, what? It's an oral final.
Yeah.
Okay, so we have a few things here. We have a written final to do. We have presentations to do, and then we also have the oral final to do. Now, the oral final, did we skip that one, or did we have an oral final?
We had it.
Okay, so
What is?
You could skip it this
yes,
semester though.
correct.
Yeah,
Uh-huh.
I'm skip it this semester.
I mean, if you
Okay,
wanted to skip
okay.
last semester, you didn't, you could skip this semester.
Aw,
But then
So-
again, it's worth
No, because the
what is
juniors got
percent or
theirs
whatever,
skipped,
and
so we
so
should get
then
ours
he
skipped
would
and
put
they
like
shall
an
skip
extra
theirs.
20% on the written final.
No,
Worse.
I'm gonna do
For 2 weeks.
Yes, true long Jeopardy.
I mean, yeah, but if you get lucky and someone does the same thing before you. Yeah, but preparing for it's way easier than.
so we have that. So we're gonna get through chapter 8.4, and then we'll stop to take all this good stuff here. So, oh, you know, we have an extra day. Hold on, I have 3 presentations. No, presentation.
My birthday's not on there, because it's on a Saturday.
Aw.
I already had my birthday.
Yes, you're official adults.
I am an adult. It's sad.
Do the clouds overwhelm you now? Being an adult. Okay,
Life
let's
feels short.
begin. So I'm going to take let's see, presentations. I'm going to give you guys the sheet for it. Yeah, kind of pick anything anything that relates algebra to life or something that's in the textbook you want to dig deeper into. It's one of those
I
two.
pick another coding language.
There you go.
Oh boy.
It can't be a repeat of what you did before.
Oh, what if I could add like so much more though?
No.
Dang it.
Okay,
All right.
let's jam with that. This is almost done. I'm going to go to algebra. And here we go. 7.5 is all good to go. So this is inequalities. We got half an hour to do it in. So we're going to go through it. Before we do that, since I don't have that much time for homework questions, here it is. Can you guys give me a list of homework questions from 7.3? So just give the list to me.
Honestly, anything after 21, I did not hold in.
Okay, 21 and later. Okay.
It's like, because the stuff that we had to use for them, we kind of brought into in class, but we didn't do too much with that stuff.
Did we get the correct text?
We're not gonna get to partial fractions, that's a.
I know.
Oh, that sounds absolutely.
Actually, is that concept gonna be in the later lessons?
It pops up again all the way to second semester calculus. That's why it's like, oh, okay, don't need that. But
Well, great then.
systems of inequalities, that's going to appear earlier. Dylan, anything past 21, yeah?
Yeah, it's not that I necessarily got them wrong, I just didn't understand how I got them
Oh, gotcha. Okay.
wrong. And there was, it's because it's like I was saying, for the two of them, it was concepts that we like very briefly talked about in class. So
Uh-huh.
I kind of knew what to do, I just didn't know why I was doing it.
Okay. So if you can write it, just maybe take a screenshot of your work, right? And then just kind of quickly tell me like, Mr. G, if I did not understand why I was doing this. Okay, and how about, let me do that. And that might be, and then we'll review all the homework questions on Monday anyways, all together. So at least that'll give me a chance. But let me put this in right here. At least I know that's that right over there. Okay, Dylan, will that make sense? There, and then I'll try to guide you through it. You are destroying Curry House.
I'm part of curiosity, I'm actually helping them.
Okay, let's jam.
Just for the game piece.
We're gonna do 7.5 and let's go. 7.5, we have inequalities on our hands.
I'm putting on almost 4. X squared minus 1.
So we've been dealing with equal signs so far. So we change the corner just a little bit here, and we go into less than signs, greater than signs, less than or equal to, greater than or equal to. And we've done inequalities before. The only thing that we gotta, yeah, not in systems though. So let's jam with first things first, just so we just remind ourselves. If you have a less than symbol or a greater than symbol, what you have is you have a dashed line. And the dashed line means the answer is not on the line. It's either above the line or below the line, but it's not on the line itself. If you have a less than or equal to, or a greater than or equal to, if you have that little piece right there, the little equal to piece, that's when you have a solid line on your hands. Good? Jam. Okay, so let's go with that. Next thing is, oh, that's right. So one more thing you gotta think about is this is not linear. I have an x to the second power over here. And so in this case, we have to go back all the way to this little guy, page 7 in your textbook. Do you guys remember these guys?
Oh, no. Oh, I remember.
Lines, lines, absolute value, square roots,
I love these.
quadratic functions, cubic functions, reciprocal, and greatest
I
integer.
love.
Well, they were like the same thing all the time, just changed.
Yeah, just change, So my question to you guys is this right here. You guys talk to me here. What does this look like here?
So,
Numbers,
Uh,
letters.
that's the x squared function thing.
That's x squared. It's a parabola, right? Or a quadratic function, right? It's this one right over here. And there, oh, there it is. There's my x squared. What do I do with this little guy when it says a -1 next to it?
Move it down one then.
Just move it down. So if we remember, the important points here were 0, 0. It was 1, 1, and -1, 1. Those are the important critical points. Let's jam. Hey, we're gonna move each of those down 1. So we're gonna go down to 0, -1. 1, 1 goes down to 1, 0. And these are gonna be kind of, for the most part, pretty easy ones here. Solid line or dashed line?
Solid because it's greater than.
Or actually, I should say solid curve, right? Or dashed curve. So we're going to graph this guy like this. Boom. And now the question is, it's not an equal sign. It is a y has to be greater than or equal to this little piece right here. So now we're trying to figure, okay, where is the shade going to happen? Is it actually on the outside of my parabola or on the inside of my parabola? And what I do for that is I just test a point. Doesn't matter which point it is, as long as you're very, very sure it's not on the line itself. Okay. So 0, 0 is a pretty easy one to test. That's a nice one because it cancels stuff out, right? but you don't have to test 0, 0. You can test any other point you like. The only thing is this right here. If you know that these points are over here, let's say these are all false points. Let's say I'm put it. If you know this right here, where do you know the true side is at? It can either be true or false, right? It's not one. So if I have a whole bunch of false points here, that means my true points are inside the parabola. Are we good? If, on the other hand, I get a whole bunch of false points that are inside the parabola, these are all false, false. You know, the other side is true. Are we good? Because there's only two options. So we want to test. We want to always shade the true side, the one that's actually the solution. If we find a true solution, we shade that region. If we find a false solution, we shade the other region. So let's jam. 0, 0, is that good? Our test point is 0, 0. Plug in a 0 in for the y value, plug a 0 in for the x value, and is that true or false? It is true. Okay, my 0, 0 dot was right here. This is true. So my shade is right here. This was all.
So if one dot works, then the entire section is shaded.
All of them are going to work.
So if 0, 0 is in, if it's inside, we can always do
If as long as it's not on the line or not on the curve. Yeah, absolutely. As long as.
all we have to do with these is,
Oh no, we're going to get more fun than that. So let's jam here. Let's see. Oh, I meant to do this here. Can you sketch? Actually, I meant to get rid of that. I meant to just say X. That one. We're going to graph this. Oh, bummer. Look at that. We actually have two inequalities. Okay, since we have two inequalities, we've got to do them both, right? And see what happens here. So, and these ones is kind of funny because this one doesn't have a y next to it at all. So my question is, do you guys remember this one from some time? If x is only by itself, is that a horizontal line or a vertical line? Vertical, awesome. So it's a vertical line at -2. It's kind of like this right here. We good? So let's jam. Solid or dashed? Dashed line. Okay, so I have a vertical line here coming down. Is that good guessing by Abe, or did you know?
oh, I know.
Okay.
Yeah. No, I just guessed. Figured out a 50 chance. But it's always a dash unless it's greater than or equal to, or.
Yeah, we have the equal to sign on the bottom, then it's a solid line. Okay, let's jam. We're gonna get through some of these here as much as we can. So I need a test point to test. Is it shading on the right side or the left side? I don't know. In fact, this is really saying, if you think about this, we're saying, I want all the x values that are greater than -2.
So it's on
Where?
the right side.
To the right side, absolutely. If you test 0, 0, notice what's going to happen is you're going to get a true statement, right? So all the x values, and shade this kind of lightly, all the x values that are greater than -2 are on the right side of this dashed line. But this guy's a system. There's two inequalities. And so now let's graph this guy. Vertical or horizontal? Horizontal. 1, 2, 3, like this.
Not
Oh, that's a solid line. Everybody good there? So talk to me if you still have questions. It's a solid line, horizontal, coming straight through number 3 or 3 here. Ooh, I want all the y values in the world that are less than 3. Less than or equal to, yeah.
Still plug in 0, 0, right?
You can still plug in 0, 0. Uh-huh.
And then if that works, you just
Okay.
find out where the shading is.
Yeah, let's see if it works here. So 0 goes into here, true or false? True. Or think about it is the y values here are what, 6, 8, 10. They're actually listed right here even, right? All the y values that are less than 3, they're all under the line itself. So I'm going to put a dashed line like this. So I'm shading this way now, right? I'm shading this way. And notice there's two inequalities. So now the question is this, where is it shaded twice?
And how would we show that?
Yeah, how would you write that as an answer?
Sure, what we do is we shade this just a lot darker. That's all we do.
We don't have to write out the number.
So like if we were to do this on the homework, that's what we would show for the answer, is just that graph with the
That,
shading.
the shade itself is the answer. So you're saying anything right here is going to be, so you want to shade this darker. If you want to shade the other ones kind of like slightly light, and then with your pencil, just darken this out a whole bunch. I'm using a different color just for you guys to see it here. But that question is that little box that hits a corner right over here, but essentially it's that bottom there. Okay, so this is called a system of inequalities. We have 2, 3, 4 different inequalities that we're trying to mesh into one piece. You good?
What you get is like an answer is where they all overlap.
So,
All overlap, yeah.
so from what I understand, you're kind of trying to box off that area you want to shade.
Mhm. Yeah, we do them one at a time and figure out what the overlap is with all the shading.
I didn't quite get what you're talking about quantity zone, but I assume that's similar, right?
Okay. Oh boy, all yours to try. Go for it. We skipped example 3. I went on example 4. I just can't count. That's fine. Math teacher can't count. I'm gonna let you guys try this yourself. Go for it. When are we out of here? 35 after, right? Yeah. Okay. So let me try all yours just to try. Go for it. As you guys try, I'm gonna tell a fun story, of course. Here, Abe, you know, when you were guessing whether it was shape, there's a fun psychological story here. There was a donkey that knew exactly how to add. So what happened is the owner would say, or actually no, it was add. Yeah, it was add. So you would say 3 plus 2, and then you would say 1, 2, 3, 4, 5, 6, and when they got to 5, the donkey would actually raise his leg and stomp on the ground. Like, that is so cool. So then it was, okay, how about 1 plus 6? And then you count 1, 2. When it got to 7, boom, the donkey stomps. Like, we just figured out donkeys actually learn how to count. And so they brought in a team of expert psychologists, mathematicians, like, hey, what is this phenomenon, right? And so they did different tests. So they first saw it, it worked just perfectly. Like, what's happening here? And then they said, okay, let's set up a test. Let's have the person count slower, right? And then count faster, right? And then it's still perfect. The donkey knows how to count. So then they said, okay, how about this? How about you go behind a screen and you do that? So then you went behind the screen and the donkey did not know anymore. And so the psychologists concluded that when the person got to that number, he would just have this slight smile on his face. And the donkey actually connected the smile to, you need to stomp. And so it was kind of fun how you were guessing, like, you know, it's either the nuance of a voice, like, is it vertical or horizontal? Hey, it's horizontal. All right.
So you're just
Moral of that story, Jake's not human.
Abe is a donkey.
Abe's a donkey.
Don't worry, Abe, anything's possible in donkey language.
Say goodbye to your rights.
Just a fun story. Okay, guys, let's go with it here. So first things first is equation 1. I'm going to save that for later. We know how to do these. So this is vertical line. Hey, at -2 again. Okay, that's cool. Vertical line -2. I'm going to go like this. No way. It's actually very similar to what we just had before. No way. Is that true? Do we shade to the right? Okay, and then got this guy. This guy is the horizontal line. Solid at 3. Everybody good there now? And it's shaded below, right? So don't do your final shade yet. Okay, so I know I'm in the bottom right-hand corner. Everybody agreed? Okay, now we got this one. So this one is a connection between X and Y. And so the way we do this one is we just solve for Y. We want to get it to look like Y equals MX plus B.
Did you just solve with the equality of equal time?
We are going to accept, we know this already, whenever you divide through or multiply through by negative, you have to change the inequality. So everybody okay there? And you guys remember this from a long time ago, like October, I think. We got this little, woo, I said, do that little spinner thing. Uh-huh. So the spinner thing says if you divide through by a negative, multiply through the negative, you have to change the inequality or switch the inequality. Okay, negative x divided by negative 1 is positive x.
Wait,
Positive 2 divided by negative 1 is negative 2.
so you don't do it when dividing by a negative number, you just do it when you're dividing by -1.
No, by any negative number.
But you divided it by negative x, but you didn't flip the sign. the first time.
Oh, it's this number right here. That's the one that constant. What did you divide both sides of inequality by?
Oh, you just subtracted it, okay. Yeah.
Good.
So then you could see the slope is,
Hey, slope is 1, is that right?
yeah, slope is 1 and you start at -2.
Perfect. Okay, let's graph this guy. Let me put a different color just so we see the contrast here, at least a little bit here. So I have -2 I'm starting with right here. And I'm going to go down 1 or top 1 or up 1.
Up 1 across 1. Right?
Okay, up 1 across 1. And then I can go maybe one more time, up 1 across 1. The rest of it I can graph solid or dashed, all yours, solid or dashed. Can be both.
Right? It's
Oh yes, it's dashed because this guy, right? Dashed. Okay, now the question is this, above the line or below the line? So on linear functions, it's actually kind of easy to tell as long as they're solved for y. Just like we solved for this one, right? Notice when we solved for that one, wasn't it all the y values less than 3, right? Now I want all the y values that are greater than x minus 2. We could do that. We could also pick a test point. Let's pick a test point 0, 0. Let's plug in 0, 0. Besides 7.
greater than 0 minus 2. Yeah, that's true.
That's true. Okay. So here it is. We have a third shade on our hands, guys. Look at this. So we're going to go like this now. So question is, keep things straight in your mind. Where is the
7, the triangle.
Yeah, it's
the triangle? Right there in the middle. So it's this little piece right here. Now I'm going to shade it in a lot darker.
Can you not see the triangle command? Can you see it now?
There we go.
Once I shade it in. All right. Are we good? Okay. Let's see. We don't have time to go over the application with, so I want to at least tell you guys here. So this way, in corporations, when they look at this here, this could be a like a profit function. Usually they're curved, they're not straight. So what happens is we understand if there's a minimum to profit or a maximum to profit, it's going to occur at the endpoints. So the testing of the endpoints is important. I forgot to print out. It was on page. I should have. Why did I not do that?
Graph the line of y is larger than x minus 2. Because wouldn't 0, 0 also fit?
So again, Abe.
How do you graph the line of the inequality of the y is greater than x minus 2? It's in slope form. Right.
Yeah, I graphed it using that right there.
It's all form except it's not an equal sign.
You just like could there be like other lines with that?
Not this one. No, you're just saying that mx plus b, and then the slope is 1. The y-intercept is -2. It's a line, but it's dashed.
What did 0, 0 for?
Zero is not greater than -2.
0, 0 works for a solution for it. I think maybe that's the next step here. So that little piece there, I put in 0, 0. And because of 0, I knew I had a graph, I had to shade above the line this way. That's what the 0, 0 allowed me to
There's a
do.
point that works, so let's do that side.
So I first graph it like this. As that, keeping in mind solid or dashed, and then I pick a test point. So extra little work there to do. Okay, let's jam with, inequalities that are not linear. That's no fun. I got an x squared over here. So the question is, how do we do that guy? Probably the same way. That's what we had the other one. So I'm gonna kind of jam as we go. Let you guys write down the problem. Let's do the linear one first, real quickly here, because as we did that already before. I'm going to add x to both sides. Are we good there? Adding x to both sides gives me this right here. Can you guys graph that with a shade? All yours to graph it with a shade. I can't see Dylan and Charlie well. Are you guys okay there?
Yeah.
Charlie, good? Okay. Okay, I am going to go with, let's see, starts off with 1, right? What's my slope? 1. Solid or dashed?
Solid.
It's a solid line. Awesome. Okay, let me extend this out. Try to make it as straight as possible. Boom, boom, boom. Good, good, good. Dylan, go.
I was gonna say, why didn't you flip the sign, but then I realized I was looking at the, wrong line.
Oh, the other one? Uh-huh.
Yeah.
Okay, test point, or do you know which way it points? Or where's the shade, or should we do a test point?
Shouldn't it be on the right side of the wall?
Yeah, because it's a less than. So
It's a less than, yeah. We're gonna shade this way. As long as we kept this sign correctly, it's gonna shade. And then let's just test it just to make sure. 0, 0 here.
The 0 is less than or equal to 0 plus 1, 1. So
Perfecto. Okay, so the shade is downward. And that's kind of what we say. The shade is downward because it's kind of below the line-ish. Okay, let's go this one. Whoa. Let's go with this one here. I'm going to, oh man, we got a little bit of work here. I'm going to subtract x squared from both sides. Negative y less than or equal to. Notice I'm not flipping the sign because I have not divided through by anything or multiplied through by anything. Should I multiply through by -1?
Probably because you can't really do anything with the x squared when it's negative.
You can't do anything because you have that little -y. That's the problem. We're trying to solve for y. So let's divide through by -1 here. Divide through by -1 here, and we switch this sign. Go ahead.
I did it by adding the line, subtracting 1 from both sides.
Oh, perfect. Yes, that's perfect. Yeah. Notice it's going to be exactly the same. As I switch this inequality around, Isabel, we get the same exact stuff. Okay, does that guy look familiar?
Oh, yeah.
That's the original one that we started with.
Yes. Okay, cool. So let's graph this guy. This is 1 below of x squared. So I got myself here, here, and here. So I have one intersection point even. And we usually, later on, if we go and take a business math class, there's such a thing, there's 2 of them, we find the exact corners here because that will give us minimum profit or maximize profit or minimize costs. Okay, so I'm going to graph this little, you go, oh, dashed or solid?
Solid.
Solid comes down, turns around, goes back up, and
Inside.
it's going to be on the inside. Okay, so 0, 0 is my test point. It's true. I shade on the inside, and then at this point, you can almost kind of tell where is it going to be shaded twice.
That little thing.
The loopy part, okay. And it's
That's
this little,
pretty good.
uh-huh, absolutely. Good math vocabulary. Oh, awesome.
The little thingy.
The thing on the graph,
The thing in the place.
to be very specific,
The thing in the place where all the math
stuff is.
The curvy part?
but like the thing.
Okay, are we good there? So this is called a solving a system of inequalities. We look for that shade, that's the overlap of all of them.
Well, it's nice you don't have to go to math to math. We just do on the graph.
Yes, correct. The shade is the answer, yeah, as opposed to algebraically and stuff. As opposed to 7.3, where you had to go through all those calculations. Oh. I'm going to skip this one. It's just to show you that sometimes you can get a no solution. Sometimes you don't get overlap. So don't need to write this one down. We'll do the next one here. This graph, what happens here, they become parallel lines. One's here and one's here. The top one gets shaded this way. Bottom one gets shaded this way, and there is no overlap. Good. That's like, oh, okay, no solution then. So there's never a time that can happen. In a business context setting, if you have so much cost, then you put the profit equation in there, you're like, I'm always below zero. There's no way I can make this happen. So it's gonna, in result, don't go into that business. Okay, but for the last one here, with 4 minutes to spare, let's grab our calculators and we're gonna graph it in order to all right, and let's see if we can put this together here. So we're gonna make a rough graph over here, but let's graph this stuff over here. So we're using those equations, and then we're gonna figure out the shade for them here. So first things first is, let's go to y equals, let's put in, so negative is over here, so negative. We put in a variable called x to the power of 2 plus 2x plus 3. There's my first equation. Click enter. Second equation is, you know what, let's do our first equation just so we can see it individually. We good?
That's negative x to what?
Negative x, and it's called a caret. It's above the pi button. It's the exponent button.
I know, but what's the exponent?
2, sorry, 2 is the exponent. 2 plus 2x plus 3. So let's go with it. 2.5 minutes left. Let's graph about where the graph is, okay? So we're gonna, as we go over here, I noticed that it actually goes through, let's see, it goes through -1, is that right? Does it go through -1 right there? I think it goes through 3. Can you guys, let's see, graph it again if need be? Yeah, it seems like it goes through and it tops off at about 1, 2, tops off at 4, right? 4, like somewhere here. And then it goes through here and it goes through here. But I'm just trying to get 3 dots somewhere in that vicinity. Okay, boom, boom, and comes back down. Question is, where's my shade? 0, 0 is a really good one to use now. I'm going to use 0, 0. And what happens is the y becomes 0. All the x's become 0 except for this guy at the end. True or false? True. Okay, so the shade is on the inside here. Okay. Let's jam with the other one here. Screen. Ding, 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 ding. Okay. So now let's graph this guy here. Let's go with y equals now. Bump it down to y2. I have myself x to the power of 2 minus 4x plus 3. Enter. So I'm going to get the second graph now. Let me see the second graph now. The second graph goes like this, comes down. Oh, awesome. I get some intersection. It looks like they almost intersect at 0, 0, 0. and they intersect right at that little 3-0 marker. Everybody good there?
Oh, yeah. And you just fill in the space.
So let's go with it. So I'm gonna go with a dot here. It's like somewhere here. I'm not sure if it's exactly the dot, but I know for like it looks like it's here. So let's come down this way. Oh, and does it come down? 1 second. I gotta make sure it
It goes below the,
goes below, right?
Yeah.
Perfect. Okay. Boom. Okay. So let me redraw this. It should go below here, and then it comes back up like this. Chunk. And then it comes like this. Okay, that's cool. Okay, give me a shade. Is it on the outside or on the inside?
It is
Maybe.
inside because if you plug in 0, 0, it's wrong. And 0, 0 is outside.
Oh, cool. This one is a false statement this time. Oh yeah, kind of careful here. Look at that 0, 0 right there.
Egg-shaped blob.
but it's
Yes.
0 is greater than 3, and that's false, so it has to be inside.
Uh-huh. So I'm gonna go with this shade right here, and the shade is again, using very precise mathematical language, it's this egg-shaped blob.
I love math sometimes.
Sometimes.
Okay, with that, we are done for the day.
When it comes to math, when it doesn't sound like
Uh-huh.
it's gonna get taken off the table.